along with g of n. Okay, so two arguments are here. One is, why not I just rely my decisions on g of n and work with uniform cost search. But uniform cost search जो है वो क्या हो सकता है, उसका ड्रॉबैक ये हो सकता है कि मेरे पास जो एडिशनल इंफॉर्मेशन है उसका मैं यूज नहीं कर रहा हूँ, तो मैं अननेसेसरी किसी डायरेक्शन में मेरा सर्च को आगे बढ़ाते जाऊंगा और फिर से मुझे दूसरे डायरेक्शन में जंप लेना पड़ेगा, क्योंकि मेरा वो डायरेक्शन में कॉस्ट बढ़ते जाएगा. Okay, and that can be avoided if I have an experience of solving the problem. So I will early in the expansion would understand कि एक डायरेक्शन में मुझे जाना नहीं चाहिए, क्योंकि वो डायरेक्शन में गोल नोड तक रीच करना मुश्किल होगा. फिलहाल अभी तक का सॉल्यूशन, माय पाथ कॉस्ट इज गुड, बट लेटर ऑन इट इज गोइंग टू इंक्रीज. ये मुझे कैसे पता चलेगा? थ्रू द एक्सपीरियंस, पास्ट एक्सपीरियंस. थ्रू द एच ऑफ एन I will understand that ये नोड से गोल नोड तक पहुंचना कितना दूर है, कितना पास है. That is the information that h of n stores. Although it is estimate, but that estimate would get better and better uh, as the agent is solving the same problem again and again over the period. So the estimation is going to be more appropriate, and many of the scenarios like traveling in a city and other scenarios that we talk about as examples, there we have certain heuristics which are universal and which follow certain physical laws. For instance, if I have cities and I'm navigating the cities, the geographical straight line distance between them is going to be a accurate estimation of cost as far as the distance based cost is concerned between two cities. Okay, so what I mean is, say suppose this is one city here and this is another city here. I may have multiple paths taking me from from one city to the other. Maybe I have one path which goes to this place, and then it comes over here. Then I may have another path that basically goes very straight, but then later on turns out to some sidelines cities and then reach the goal node. Okay, and I may have one of the path which is the straight line distance geographically. So this third path that I have drawn, and I may use some other color to draw it. I don't like actually different colors, but then unfortunately showing these things manually here, I need to use colors. So this is the straight line distance. This straight line distance obviously is going to be the least cost path between these two nodes. So ये जो least cost path है, स्ट्रेट लाइन डिस्टेंस एज ए ह्यूरिस्टिक अगर मैं यूज किया तो ये एस्टिमेशन सबसे अच्छा एस्टिमेशन हो सकता है फॉर अ ज्योग्राफिकल area which I am navigating for such problems. And we'll see how it fares as a heuristic later on when we discuss these algorithms, and we'll see examples of these algorithms. Okay, so what we need to understand here in the whole discussion that we have today so far is best first search algorithm is a class of search algorithm. It's not a single algorithm. Best first search algorithm bases its use or bases its selection from the fringe list based on a function which is referred to as evaluation function. Best first search has root in the uniform cost search from the uninformed search category of algorithms. What it does is it also uses the priority queue as the fringe list. But the priority is not based on g of n, but it is based on f of n. So from a best first search algorithm, I can instantiate it as a uniform cost search algorithm by saying I will use f of n is equal to g of n and make it a uniform cost search, which is an uninformed search category of algorithm. But when it comes to use of some domain understanding or domain knowledge or previous experience of solving a problem into the problem solution, I can use heuristic function or h of n as my evaluation function. If I base my priority queue of fringe list using h of n purely, then I am actually relying my decisions of selecting next node based on how far this node is from the goal node. And how far is the goal node, this node is from the goal node can be estimated by using or remembering the cheapest path from the current node to the goal node. It's an estimation of the cheapest path from the current node to the goal node. Okay, the implementation would be, as they say, we are ordering nodes in the fringe list in the decreasing order of desirability. Okay, so how much cost? So decreasing order of the cost, based on that we will organize the node. Is it correct, decreasing order? So high cost node, then low, then low, then low, least cost node. I guess it should be in increasing order of the path cost, the h of n. It should be. We'll see that in the next slide. Maybe I'm just worried about this, and we will correct it later on, maybe, or we will assure that it is decreasing order. Fine. Two special cases of best first search is, one is the greedy best first search and the other one is A star algorithm. In greedy best first search, we use f of n is equal to h of n. This is how we rely our decisions. In greedy best first search, the red algorithm, and the yellow algorithm, the A star algorithm, we use the f of n is equal to h of n plus g of n as our choice of f of n. Okay, so this is about the class of algorithm which are called as best first search algorithm. Now, going back to our Romanian traversal problem, it's a person who is currently at the Arad who wants to travel to Bucharest within a stipulated time. Okay, so he has to go to Bucharest in least amount of cost, and the cost is defined in this particular diagram as some distance cost from a node to node. So Arad to Zerind, A to Z, as we see over here. This is Arad and this is Bucharest for you if you don't know the Romanian graph. So I want to travel from Arad. So this is my initial state in Arad, and in Bucharest would be my goal state. So my goal test would be to check whether you are in Bucharest or not. Okay, and these are the numbers written over here: 75, 71, 141, 151, 118. These are the cost for that particular movement. So if I start from Arad and I reach Cebu in following this particular path, it will cost me 140 units. Okay, it could be in distances, then it is 140 meters, I would say, or kilometers, I would say, something like that. Okay, we are not interested in what is the unit, we are interested in that absolute value, 140 units. That's why I've said that is units. But as I have a notion that this particular column over here is actually the h of n function. What is h of n function? The estimation of reaching the Bucharest from that particular city. So if I'm in Arad and I want to check, I want to estimate what would be the cost of reaching Bucharest from Arad, it is coming out to be 368. It is coming out to be 366, sorry, not 368, 366. If I'm in Bucharest itself, the cost naturally is 0, h of n, because I'm already in Bucharest. So Bucharest to Bucharest, cost is 0. Minimum cost path is, the cost is 0. From C to Bucharest is 160, and for other states, it is written over there. So A, B, C, D, E, F, G, H, I, J, all the cities are mentioned over here. Okay, we have 10 minutes. We'll just quickly look at how the greedy version of our algorithm, best first search algorithm, would work. Okay, now we need this table with us always. So I'm going to do one thing. Give me a second. I'll just take a snap of it. Last year I did not know that we could take snaps like this, so I actually wrote everything and it was a cumbersome thing. Now, greedy best first search, we say, as we said, f of n is h of n. Okay, sorry, it's again need to change it to link. Okay, so f of n is h of n, and h of n for this problem is h straight line distance between n and the goal node. That is the straight line distance from n to the Bucharest. So every node I will give input to this function hsld, and it will give me a number, and that number tells me what is the straight line distance between that node and the goal node. ये इंफॉर्मेशन मुझे एक्सपीरियंस से मिलेगा नहीं, ये एक्सपीरियंस मुझे, ये इंफॉर्मेशन मुझे मिलेगा looking at maybe a graph or a map of the Romania. So if I have a map of Romania, I can use scale of that map to understand the straight line distance. That's all what they did. So what is the straight line distance, by the way? Just as a confirmation, I will say straight line distance from Arad to Bucharest. When I say, then I'm actually measuring, okay, this. Okay, and you'll find that there are a lot of path going starting at Arad and reaching Bucharest. The straight line distance is going to be the least cost path. ये मेरा assumption है, क्योंकि आप कहीं भी ज्योग्राफी में देखोगे, एक जगह से दूसरे जगह तक जाने के लिए स्ट्रेट लाइन डिस्टेंस जो है वो सबसे शॉर्टेस्ट पाथ होता है. That is why it is chosen as a heuristic for this problem, because it's a geography traversing problem. तो geographical जो rational है, जो understanding है हमारा as a human being, जो कहता है कि कोई भी दो सिटीज में अगर मैं उसका लैटिट्यूड लॉन्गिट्यूड लेके स्ट्रेट लाइन निकालूंगा और डिस्टेंस कैलकुलेट करूंगा यूजिंग डिस्टेंस फॉर्मूला x square plus y square the whole square root, that distance is going to be the least one. And nobody is requiring you to calculate it. It is given to you in a table manner. Straight line distances to Bucharest from the particular city. Okay. So now the algorithm does what? The algorithm does like this. So when it is in Arad, it will actually figure out what is the straight line distance. So now the additional information is stored in the node data structure, and that is the cost going to that particular node. Okay, not here, it is in library. Sorry, I did wrong thing. Pictures, pick that up, keep it here. Okay, so this is the table. So I look at the table, my initial node is Arad. So Arad's straight line distance is 366. There is only single node in my fringe list, so not to worry. एक ही नोड है तो मुझे कुछ कंपैरिजन नहीं करना, प्रायोरिटाइज नहीं करना. नेक्स्ट स्टेप व्हाट विल हैपन इज, ओके एवरी टाइम करना पड़ेगा, ओ शिट, सॉरी, रॉन्ग वर्ड टू यूज. नाउ कमिंग बैक हियर, as I expand Arad, I generated three nodes, S, T and Z. So if I see S in this particular table, S is here, T is here and Z is here. So S has a cost 253. Okay, T has a cost 329 and 374. By the way, these are not costs; these are straight line distances between these cities and Bucharest. So a straight line distance between Cebu and Bucharest is 253, written over here, 329 written over here, and 374 written over here. In the data structure, actual data structure, what we will have is, we'll have them 253, 329, 374 organized as increasing order of straight line distances. So least distance वाला node, जो least cost वाला node होगा, वो मैंने select किया है next expansion के लिए. That is why that red arrow is over there. Okay, I hope this is understandable. Next I will do what? From Cebu there are 4 nodes, so I will be putting these 4 nodes along with T and Z in my queue. So in my queue along with T and Z, I need these nodes. And just for your information, these numbers are, from Cebu I can reach Arad with 366, Figueres with 176, U with 380 and HV with 193. So I have to add 1, 2, 3, 4, 5, 6 nodes in my, I need to have 6 nodes at this selection point. Okay, 1, 2, 3, 4, 5, 6 nodes are there. They are organized in increasing order of their straight line distances to Bucharest. Okay, so the next node that I select is F, which is 176. So I select this node and I go ahead. Similarly, when I expand Figueres, there are 2 paths. One goes to Cebu and the other one goes to Bucharest. And I put these both things into my list. So Bucharest 0, RV is 193, S is 253, T is 129, and that's the current fringe list. But Bucharest is in the lead. So I will be picking up Bucharest, and Bucharest is my goal node, and that's how I actually reach my goal node. Okay, so we'll stop our discussion here. I have another lecture to catch up.